Today we're going to be unboxing and assembling a Celestron Starsense 114 Explorer LT. It's one of the entry-level telescopes in the Starsense series. Now that it's assembled, I'll show you all the parts. It has a red dot finder. The red dot finder has a little piece of plastic. You have to pull that out or it won't work. That's to keep the battery from running down. It has it's an alt-azimuth mount. It has a altitude bar here for fine adjustment of altitude. It has the mount is a yoke mount, very, very light. It's about 438 millimeters long, 1,000 millimeters in focal length. So this is a Bird-Jones type Newtonian. It's a pretty little telescope, easy to assemble. For a beginner, there's a bunch of instructions here that show how to do it. Here they are. I'm not a beginner, so I didn't read them. It took me about 10 minutes to assemble it. This right here is the Starsense cradle. This is what makes this telescope neat. You put your cell phone in here. The camera from the cell phone looks into this little mirror here, which sees what's going on in the sky. You pick a target and it guides you with little arrows telling you if you should go up or down, right or left, until you're on the target. Never tried this thing before. I'll be going out to align the finder scope as soon as it stops raining, and as soon as it clears up, I'll go out and see if I can figure out how to run this thing. The scope itself didn't take very long. It took me about 20 minutes to figure out the cradle, how to set it. And I've got it all set right and everything. There's a screw under here with a couple knobs. You turn those to move your telescope back and forward, up and down, until the camera is centered inside the mirror. Not bad, really. This is a Newtonian, and being a Newtonian, you'll have to adjust the mirrors when they get unaligned. This particular one, I checked it. The mirrors are perfectly aligned. So it'll probably be a while before it needs adjustment. Once it does, there's a little thing here you pull out. There's 3 screws. You move those around to align the secondary mirror. Then in the back, there's 3 sets of screws. Lockdown screws and collimation screws. You loosen the lockdown screws, move the collimation screws to adjust the primary mirror. Once it's adjusted, you tighten the lockdown screws again. In fact, if you look into the tube, you'll see something like this. There's 3 lines here. There's 3 veins. They're called spider veins. They have to be perfectly centered. All 3 have to be the exact same length. There's then 3 mirror clips. They have to be exactly alike. The amount of them showing has to be the same amount. And of course, this right here is the focusing tube. This right here is the secondary mirror assembly. It does come with some accessories. It comes with a 25 millimeter eyepiece, a 10 millimeter eyepiece. You normally use the 25 millimeter eyepiece first because the magnification you get is the focal length of the telescope, 1000, divided by the focal length of the eyepiece. 25 goes into 1000 about 40 times. So this gives you a magnification of 40. The 10 millimeter eyepiece it gives you greater magnification because 1000 divided by 10 is 100. So the 10 millimeter eyepiece gives you 100 magnification instead of 40. And it comes with a ×2 Barlow lens. That's a special kind of an eyepiece thing. What you do is you stick the eyepiece into the Barlow lens and stick the Barlow lens into the focusing tube. That doubles the magnification. The 25 millimeter eyepiece works pretty well with it. I have another pretty much identical optical tube. That's my Celestron 114. These are identical as far as the optics. They're different color, and this doesn't have the cradle and that doesn't have the dove bar, but they're pretty much identical other than that. And so I'm used to using this optical tube, and I kind of like it. Anyway, so there we have it. Easy to assemble. Oh, very light. I would recommend strongly that before you use this thing, you put a weight in the oh yeah, that helps a lot. Put a weight in the accessory tray. That'll help hold it down by lowering the center of gravity. Anyway, we'll take this thing out and give it a run through. I watched a number of videos on this thing. It's very popular with some people. We'll see if they're right. Well, I'm out here aligning the red dot finder with the optical tube. When you do that, you always use the 25 millimeter eyepiece, never the 10 millimeter eyepiece, and that's because you'll find the higher the magnification, the narrower the viewpoint with telescopes. So with the 25 millimeter eyepiece, you get about 1.5 degrees field of view. With the 10 millimeter, you get 0.52, about 0.5 degree, which is about the width of the moon, full moon. So the 25 millimeter gives you 3 times the field of view. If you're trying to find something, a big field of view is handy to have. You're not looking for magnification. There's a sign down there about 3 blocks away. Behind it is I can't see it without the telescope, is a red fish on a stick. That's in front of the art department. I chose that since it was fairly far away, and I aligned but what I did was I moved the optical tube like this until it was on the target. Then I locked it down using these 2 things. Oh, I made sure it was focused. And I went over here to the red dot finder, turned it on by using this knob here. It's a little rickety, so you have to kind of hold this thing down. This knob here made it go back and forth. This knob here made it go up and down. I moved them until the red dot was on that fish. First time, by the way, I've ever used a red dot finder. I normally use a 90-degree direct view finder. Then I decided I would see some of the video, most of the video, I've watched like a dozen videos. Most of the videos said you had to align the camera at the telephone at night, pointing at a star. One fella did it in the daytime, just aimed at an antenna a few blocks away. Disadvantage of that is, once you've aligned it, you can't take the phone out of the cradle. Can't do anything with it, or you'll have to realign it. I wasn't able to do that, however, because the sun's so bright, I can't see anything here on my telephone. Nope, nothing at all. So I'm going to have to wait until I can come out at night to align my phone to it. What I have found so far is, see this here? I don't know if you can see this or not. This is real rickety. This isn't my only mount. It has this horseshoe shaped thing. They're all rickety like that. That means when you're trying to center on an object, you center it, and then when you let go, it'll fall below the object you're trying to center on. Then you use the slow motion control thing here to raise it back up a bit, and you're on target. Anyway, we'll find out how this thing works at night. Once I can get just a little bit of break in the clouds, I don't have to have a perfect clear night. That's all for now. Yesterday, after I finished aligning the red dot finder to the optical tube, I decided to try to align the telephone with the optical tube. Watched several videos about this. Most of them said you do it at night, pointing it at a star. I hated that idea because I can't bend down far enough to use a red dot finder looking up at a star. One video I watched, a fella did it in the daytime by pointing at an antenna several blocks away. Well, I'll try that. There was a lamp, a night lamp, above a door about 2 blocks from here. I pointed it at that, put my camera in, could not get the thing to work, save my life. I couldn't see anything in the camera. Couldn't see anything at all. Made a note of that fact, went to bed, gave up. But before I went to bed, I decided to go ahead and edit the video I'd made yesterday. And during the editing, I noticed that the dust cover, this thing here, was still on. I was still on the cradle. I hadn't taken it off. So the mirror was, all it could do was reflect the inside of the dust cover, the black. Kind of embarrassing, but no more than when I go to take pictures at night, I can't focus the telescope, and I think maybe I should check the dust cover on the front of the optical tube, and sure enough, I've left it on. If you're going to get in this hobby, you want to try to be less forgetful than I. In any event, I got up this morning, took the dust cover off, and it worked fine, amazingly fine. There's some instructions. You open the app up and it tells you what to do, and there's like 5 different things you got to do, and mainly it's point the telescope at something, and then the app gives you it takes the picture from the camera You can move it around, you can enlarge it, and you find the thing you're looking at in your eyepiece and make it the center of the screen and then tap it. And that's all there is to aligning the camera with the optical tube. I have several go-to scopes, and there it takes about 15 minutes to align the camera with the software, because you have to find at least 3 different spots in the sky, use your hand controller or your telephone if you're doing it with a telephone, move the thing over there and get it on it, then go to the next one. With this, you just point the camera, which is on the phone, just point the camera at the same thing the optical tube is pointing at once. Amazingly fast. It took me a minute and a half. And that was trying to figure out what I was doing as I did it. Normally it takes about 15 minutes with the go-to system. So, and I've been thinking, that's not really a technological difference. Either way, you're using a camera and you're doing plate solving. Take a picture of the sky, look at the configuration of the stars, compare it to what's in your memory bank, line it up, and think, that's where we're looking. It's the software, the way it's programmed. Oh, and you can't star align a go-to at night. I mean, in the daytime. You have to go out at night. With this, I did this one in the daytime. I just pointed it actually I pointed it at the window, because when I looked through my telescope, there's the window and there's the night light right above it, which is upside down, so it's below it. And then I went into the cell phone. I couldn't see it. It was too small. So I went back out to the eyepiece and moved it over using my vertical control bar, moved it up a bit so it was on the center on the window, and I could see the window in there. Put it on the window, bing. Now the disadvantage to that is I can no longer use my phone. I can't take it off the cradle. It's on the cradle till I go out and look at the sky, and I have to align it obviously every time I'm going to use it. Well, I might not have to. As long as the phone's in the exact same spot and the cradle hasn't moved, I shouldn't have to realign it. I'll test that. But in the meanwhile, it's real easy to star align this thing without a star, just looking at a window 2 blocks away. Of course, I do astrophotography, and this won't work. I tested it this morning. This technology, the software will not work on an equatorial mount. It only works on a up and down, sideways, alt azimuth mount. If you try to move it with the right ascension control, it immediately loses alignment. It doesn't know how to handle right ascension motion. So it would be, of course, also it's not tracking. And you need to be able to track the star that you're taking a picture of in order to take a picture of it. So this is designed for visual use. And if it's as easy to use as it was to star align on a window, it's going to change my opinion a whole lot. One thing I did notice about it, though, this cradle mount, yoke mount, the yoke mount is really rickety and hard. If you're not used to one, it's hard to use, harder than a handlebar mount, and I don't like those. And this is like $230, cheapest one. Next one's like $360, and they go up from there. They got, like a Well, they got another cheap one like this for 80 millimeter refractor. But then for about an extra $130, they got a 102 refractor, and 130 millimeter reflector, and then they've got a Schmidt Cassegrain for a couple of $100 more, and Microsoft Cassegrain. One fella, a guy named Joe Jaguar. I'll try to put his URL, his YouTube's channel, in the bar below. He loves these things. He bought one and thought it was kind of rickety, so he just unscrewed the screws and took it off and screwed it onto a 12-inch Dobsonian. He liked it so much he went out and bought another one just like it, just to get the cradle and the software. Oh, you have to type in a special code to use the software. You only have to do it once, but you have to buy the telescope to get the secret code to type in. In any event, I'm spending a lot of time here talking in my absolute joy of seeing how easy it is to align the camera on a cell phone with the optical tube. It may be clear tonight. It may be clear tomorrow night. I'm not sure which. Moon's going to be out, so if it is clear, I might be able to get a picture of the moon with this thing. Hold my camera up to the eyepiece and snap it, the camera shot. Who knows? In any event, tonight or tomorrow night or whenever I can get out, I'll see you then.